Hey everyone, welcome back. Today's day 3 of my 30-day fan grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Currently, I rank in the top 0.3% on LeetCode at a global level, and I'm also preparing for FAANG interviews like most of you. Yesterday, we tackled two-pointer techniques, and today we are jumping into prefix and suffix-based problems, which is super common in arrays and strings and a favorite theme in fan interviews. We will also sneak in a few sliding window refreshers to keep all those patterns sharp. Before we begin, if this helps you, please give it a like, share with someone who is prepping, and hit that subscribe button so that we can all crack interviews side by side. Let's get started. So today, the problem number 3 is 238 on LeetCode, product of array accept itself. Okay. So the problem says that we have been given nums, an array, and we have to return an array such that it outputs the product of the array such that it do not includes the element at a specific index. Okay. Okay. What do I mean by that? Let us go to the dashboard and we'll try to investigate and answer it. But before we go to the dashboard, let us look at the time complexity. The constraints over there. Okay, because it will help us to choose the optimal path. Okay, so we see that it goes to 10 to the power 5 and nums is in the range of -30 to 30. Okay, let us go to the dashboard and we'll investigate and try to find the solution for this problem. All right, so the problem states that we have been given an array nums and we have to return the product of array except self. What do I mean by that? For example, as you can see, the output of this nums array is this thing. Okay, if I look at any specific index, let us suppose at index 2, we see 3, right? What does it mean? What does it mean by product of array except self? It means except this value, we have to return the product of everything on the left times the product of everything on the right, which is equivalent to what? 2 times 1 is 2, 4 times 1 is 4, 4 times 2 is 8, right? And it is something that we return at this specific index, okay? So I hope you understood what the question is demanding out of us, okay? Now, how do we approach this problem? There are two ways in which we can approach this problem, and I will tell you both of them. The other way, which is the second way, is little bit more space optimized than the first one, but again, you can follow either of those ways, okay? So let us see what I have done here. I have created two different array. The first is the left array, and the second is the right array. What does it mean? Left array implies left array gives us the output of the product on the left of that index. Okay, what do I mean by that? For example, if I'm at index 2, so the left array will store at this index the product on the left of 2, okay, which is 1, correct? If I'm at 4, so what is the product on the left of 4? Excluding 4, it is 6, right? 3, 2, 1, correct? In the same manner, the right product gives the output for the right part of it, excluding the index itself, okay? Now, since okay, so how do we generate both this left and the right array? We generate it using this template, okay? A stands for array, left stands for the left array, R stands for the right array, and A stands for the array, okay? And as you can see, since once we generate those two arrays, okay, our output, our answer will simply be the product of individual index. All right, like this. It is pretty simple, okay? If you think of about this in a different manner, for example, let us suppose I have to find the product of this index except self. How do I find this? I find the product of everything on the left, which is found by left array. I find the product of everything on the right, which is found by the right array. And once that is found, like 2 and 4, how do I manipulate and output this thing? We just multiply these two things and we output here, right? So that is what it is getting done here. And this is the specific, or you can say the valid syntax to compute left and right array for this specific case, okay? Now, how do I optimize this? Instead of keeping a right array in a separate manner, what we can do is we can prepare right array on the go using the left array, okay? And return the left array as the main output. What do I mean by that? Let us consider an example here, the same example as above, 1, 2, 3, 4, and we generate a left array. 1 1 2 2 6, which is pretty identical and exactly like the one that has been generated above. Okay. Now, how do we generate right array on the go? To generate right array on the go, what we need is we need to create a separate variable, and let me call it post variable. Okay. Initially, its value will be 1. Okay. Now, let us look at this point, this left array. Okay. What can we say about left array? If I'm trying to generate the value on the right of that thing, how do I generate it? Let us look at a specific example. For example, let us look at this part, okay? If I am at 3, how do I generate and store the result on the right part over here, right? How do I do that? I do that using this specific syntax, okay? This syntax. Every time I'm at a specific index, I will be iterating from the right to the left, okay? Every time I'm at a specific index, I will multiply post. Post is initially initialized to 1, and you can think that post is initially at the outer bound of the array, okay? It is at the outer boundary of the array, and it is initialized to value 1, okay? Let us see how it goes. Initially, left I, which is at this point, because we are traversing from right to the left, as you can see over here, okay? Initially, the left value will be 6 times, post is here, right? 6 times 1, the left will be stored to 6. Okay, then what will happen? Post value, it will shift and come over to the current value that we are looking at. Okay, and this current value that has been stored in post, it will be utilized when our index moves to the next value. That is why it has been named the post. Okay, so that is what it is happening over here. I can do a dry run pretty quickly. Okay, let me do a dry run, that might help. So I'm at this index, right? Initially post is 1, okay, and I'm at this index. Let us see what it says. Left of I times post. Left of I is 6, correct? 6 times post is 6. My index comes over here, but before index comes over there, my post will change to a of I times post, which is 1 times 4. Post will become 4, right? Now I'm at this position, 2, correct? Left of I will be like 2 times what? 2 times post. 2 times post is what? 4, right? And before I move my index over here, my post, it will change to what? It will change to this current value, right? Times that, which is like 12, correct? Now I'm at this position, right? So what will my left of index I becomes at this position? It will like 1 times post. Post is 12, correct? Before my index moves to the first position, the post will again update because the index is here, right? Post will transform itself to 12 into 2, which is like 24, correct? Now the index is here, the pointer is there. So the value of li will be 1 times 24, which is 24, right? And it is exactly the same output that we require, 24, 12, 8, 6, okay? So yeah, that was all about there is to this problem. The time complexity, as you can see, is determined only by a single loop over here, and it is bounded within the linear complexity of order of n, and the space complexity is just this thing that we're needing here, order of n, right? So yeah, that is all there is to this problem. Let us go to the LeetCode dashboard and we'll try to submit this problem and run it and see how it goes. Okay, I'm on the LeetCode dashboard and I have already submitted a solution. So I will just copy and paste my solution, okay? And I will try to run it. And as you can see, the solution has been accepted. So that was all there was to this problem. It was an interesting problem, especially how we manipulate space and how the pointers are moving. Okay, so we need to keep those two things in mind. Yeah, so I will see you in the next video.